All right, in this video, we are going to take a look at the tangent graph. So take notes. This is still 4.1, and now we are doing part 3, the tangent graph. Okay? All right, so tangent graph. All right, y equals tangent x. So here, let's recall that tangent is just sine x over cosine x, okay? And let's make our table of values here so we can understand where the shape of the graph comes from. Okay, so we will take a look at 0. And over here, between 30, 45, and 60, I like 45 because tangent of 45 is 1. I don't need a calculator. Okay, so we'll do pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4, 3 pi over 2, 7 pi over 4, and back to 0, which is 2 pi. All right, so okay, so we know that sine of 0 is 0 and cosine of 0 is 1. So 0 over 1 is 0. At pi over 4, sine and cosine are the same, so we get 1. Now over here, this one is interesting because sine of pi over 2 is 1, but cosine of pi over 2 is 0. So 1 over 0 is actually undefined. Undefined. Okay. And then we're at 3 pi over 4, which is quadrant 2. So sine and cosine are the same, except that cosine is negative. So we get -1 here. And then tangent of pi, sine of pi is 0, cosine pi -1, 0 over -1 is 0. 5 pi over 4, we're in quadrant 3. So both sine and cosine are negative. So 5 pi over 4, we'll get a +1. 3 pi over 2. Okay, so 3 pi over 2, sine is -1, but cosine is 0. So -1 over 0 is undefined. Okay. 7 pi over 4, we are in quadrant 4. So we are negative on the sine, but positive on the cosine. So -1. And then 2 pi, we're back to 0. Okay. And this time I am actually going to make use of all of these points, okay? Whereas like for the sine and cosine, I kind of just needed the quadrantal angles. Here I am going to use all the quadrantal angles as well, but I am going to use these pi over 4 ones as well, okay? These fourths. Okay, so let's take a look at the graph. All right. 0 to 2 pi. I normally do it a different way, but I want to do it the way your book is showing you. They use a different. They use 0 to 2 pi pretty much for all of your graphs. I don't, because I like the parts of the graph that look more pleasing to my eye. Okay, so let's go here. All right, so 1, -1, pi, halfway in between is pi over 2. Halfway between here is 3 pi over 2. Okay, so over here, very important, where we have undefined. So at pi over 2, right here, and at 3 pi over 2, right here. Very important. Where you have it undefined, you have what are called vertical asymptotes. Do you remember that from your previous math course? Vertical asymptotes. And you have them where it's undefined. So at x equals pi over 2 and 3 pi over 2. Okay, so here I have a vertical asymptote here, and I have a vertical asymptote here. Okay. All right. That takes care of those. All right, so 0, I get 0. Pi over 4, I get 1. And then I have my asymptote here. 3 pi over 4, I get -1. Pi, I get 0. 5 pi over 4, these guys happen to be all the ones that are halfway in between. Okay. 5 pi over 4, we get 1. 3 pi over 2, undefined, so no points there. 7 pi over 4, -1. 2 pi, 0. Okay, so let's take a look at what we have. So here, you might not be able to see it with just these points. If you plot more points, if you plot 30 degrees and 60 degrees in all of the quadrants, then you might be able to see this the shape more clearly. But so here, you actually have this graph, and down here, let me extend these here. This is actually what it's supposed to look like, okay? And then over here, so this is, you actually have not one cycle, but 2 cycles here. So right here, this is what one cycle would look like connected, okay? So it kind of looks like the x cube graph, right? So it's kind of this, okay? And you see it here between pi over 2 and 3 pi over 2, okay? And so what's happening is that you actually have 2 cycles here. So it's broken into 3 pieces. And so 1, 2, 3, okay? But this is pretty much one cycle right here, okay? And this graph starts to repeat, okay? So it starts to repeat. We can see it here. So we have this piece, which is here. So we see that this started to repeat right here after pi, right? Okay, so we see here, it's right there, okay? So this here starts to repeat after pi. Every time you go to pi, you're going to start having this upper part, okay? So here's pi. So over here, you're going to have that upper part, okay? So if I extend this to 4 pi, let's go to a different color. All right, so if I go all the way here to 4 pi, this exact same graph is going to repeat. So let's take a look at some highlights here. All right, so on the endpoints, we have 0. So that's 0 here and 0 here. Okay. Halfway in between, and this is going to be 3 pi, right? So halfway in between, I also have 0. Okay. And then halfway between here, I have a vertical asymptote. So vertical asymptote here. And halfway in between here, I also have a vertical asymptote. So halfway in between here, my vertical asymptote. Okay. And this whole, all 3 pieces will repeat here. Okay. So let's see. Okay, there it is. Okay, I was trying to find where I left off. Okay, so there it is right here. So this piece will start from here because this one was just kind of left hanging there. Okay, and so we see that this piece will start to repeat after here, after 2 pi. We will have this piece, right? Drawn kind of weird. Okay, and then this piece will start over here. And then this piece, this lower piece, okay, will start. Okay, so we see that this here repeats after 2 pi, but we see the repetition happening already after pi because we see this here and here. So the period for tangent is actually going to be pi. Okay, because remember when the period is where we look for when it starts to repeat itself. And we see that this here, if we look at only this piece and this piece, these two pieces right here, ignore this, right? Only from here, this bottom part and this top part, they start to repeat starting right here. Upper, bottom, upper, bottom, upper, bottom, upper, bottom. So really, the repetition starts after pi. So the period here is pi. Okay, let's write that down. It repeats after pi. Okay, so again, hopefully you see it. Here's the upper, here's the bottom. Here's the upper, and here's the bottom. Okay. All right, so let's do our in general. All right, so in general, when you're graphing tangent, the endpoints, so let's take a look here. We see here on the endpoints, if we just do for one cycle, let's do this. For one cycle, not two. For one cycle, 0 to pi. Okay, so for one cycle from 0 to pi, I see that here from 0 to pi, I get 0 on the endpoints. Okay. And then we see that halfway between the endpoints, we have an asymptote at pi over 2. Okay. And then halfway between endpoints, we have a vertical asymptote. Okay, so here. So I'm just going to kind of draw it over here. Okay, so we have the graph where so far on the endpoints we have 0. And halfway between the endpoints, we have a vertical asymptote. Okay. And then halfway between on the left, we have, if we take a look here, we have +1. Okay. And halfway between on the right, we get -1. Okay. So halfway between on the left, we get +1. And halfway between on the right, we get -1. Okay. And we know that this will repeat over here, where we get the upper half, and then upper asymptote, then we get the lower half, and then the upper half, and then the asymptote, and then the lower half, upper half, asymptote, lower half, upper half, asymptote, and it just keeps on repeating. Okay. And what we see here from 0 to 2 pi is actually 2 cycles, and not just one. Okay. And remember here, it repeats itself after pi. So this is the period. Okay, so that is it for tangent. We're going to move on to the other 3 graphs, cosecant, secant, and cotangent. All right, moving right along.